In this example, we will evaluate the definite integral from 0 to 1 of the quantity 1 plus square root of x, all raised to the 8th power. Now, looking at our integrand and going through kind of our strategies list, first of all, there's no obvious algebraic manipulation. There's no obvious substitution that I can make. And the integrand, I would say, moreover, does not fit any of the standard forms that we've seen. So the next thing on our list would be to think about any more subtle substitutions. And looking at the form of our integrand, we do have this inside function 1 plus root x. So that's something that we could certainly try as a substitution. And remember, there's never a guarantee that something is going to work. We really have to kind of try it and then follow through and see what we can make happen. So the inside function is u equals 1 plus root x. And we're going to go about this from the perspective of a reverse substitution, much like we did when we were dealing with trigonometric substitutions. So if you were to solve for the x here, we would have square root x is equal to u minus 1, or x is equal to the quantity u minus 1 squared. And that tells us that dx will be 2 times u minus 1 du. And at this point, we see that we have enough to rewrite our integrand. We have limits of integration that we have yet to change, but we will. But in our integral, we see that the 1 plus root x is u, and the dx can be written as 2 times the quantity u minus 1 du. So the integral will become u to the 8th multiplied by 2 u minus 1 du. So once we maybe say pull the 2 out front and distribute the u to the 8th through, we will have all powers of u, and this will become a very reasonable integral. But first, we do need to change our limits of integration. So for the lower limit of integration, we have that x is equal to 0. So that tells us that u is equal to 1 plus the square root of 0, which is equal to 1. So our new lower limit of integration is 1. Additionally, for the upper limit of integration, if x is equal to 1, then u is equal to 1 plus the square root of 1, which is 2. So our new upper limit of integration is 2. And at this point, I think we've taken care of what we might consider the most difficult part of the problem, kind of getting it set up and seeing a clear approach that we can finish with. But let's go ahead and take care of the remaining steps. So pull out the 2 and distribute the u to the 8th. So this will be u to the 9th minus u to the 8th du. Now we can anti-differentiate each term individually. So that would be 1/10 u to the 10th minus 1/9 u to the 9th. And we need to evaluate from 1 to 2. So we plug in a 2, so we'll say 2 to the 10th over 10 minus 2 to the 9th over 9. And then we put a minus sign and we plug in 1. So 1/10 minus 1/9. And just one kind of overall observation to make, this really is a difficult integral. Not in the sense of taking care of these final steps, but difficult in the sense of really that initial step, deciding how to start. And remember, when you're approaching integrals, it is very reasonable that you may have to use multiple different approaches before finding that successful approach. And that's just all part of the learning process.